Number 5. Reading from left to right. For how many integers greater than 9? Is it true that every digit after the first exceeds the digit it follows? Okay, this is definitely challenging problems. Reason is you don't want to write all these numbers. It's going to take forever. You have to think something else, like you have to think outside the box for this problem. So I don't expect many people to get this unless they are trained. And I'm gonna show you how to do it by using the subset technique. I'm gonna use subset. Alright, so our goal is, before we start, our goal is how many integers? Okay, so it has to be greater than 9. Okay, so a subset, think more like a bag. Okay? In analogy, think like bag. Or like number of different kind of bag. Okay, so let me illustrate that with simple. In each bag we're gonna have some element. Okay? So say I start with 0 element. Here is the example. And I can have 1 element, 2 element, and 3 element, and 4 elements. I'm gonna stop there because 5 elements is gonna be really a lot. So what I'm trying to illustrate is when I have 0 element, that means I have empty set. Okay? That's the only one possibility, meaning empty. Now when I have 1 element, I can have something like just number 1. Okay, and also I can have empty, meaning in my bag there's nothing. So I have 2 possible bag arrangements, right? 2 possibility. And then when I have 2 elements, well, it doesn't have to be number if you want to think differently. Like I can think about like a black marble and white marble. Well, either I can have black and white, or I can have both in one bag, or none at all. So when we talk about number, we have 1 and element 1 in a bag and 2 in another bag. Okay, or we can have both in one bag. So adding these up, you're gonna have 4 possible arrangement. Okay, notice that I don't write 2, 1. The order doesn't matter. Okay, because we are exploiting that, because I'm gonna demonstrate why I'm using this technique, because I cannot have 2, 1, and our constraint in the problem set is just only increasing, right? So combination is what's very helpful here to go against the order, the importance of the order of the numbers. And then I can have 3 elements, so I can have empty set again, nothing in the bag. I can have 1, 2, 3 individually in each bag, or I can have 1, 2, 1, 3, 2, 3, and then I may have 1, 2, 3 in one bag. So counting all these, you're gonna notice there are 8 possible. Do you notice some sequence here? 1, 2, 4, 8. Well, to make sure we have the right sequence, I'm gonna do the final element here. 1, 2, okay, don't forget empty set, 3, and then 4. I can have 1 2 2 3 3 4 2 4 1 4. Yeah, I don't think I have 1 3, so 1 3. Do we have more? I don't think so. 1 2 2 3. All right. And what if we have 3 elements in the back? 1 2 3 2 3 4 1 2 4 1 2 3 2 3 4 1 2 4 1 3 4. Okay, so far we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Well, we have everything, and our final, I'm gonna set the 1 2 3 4, and I have 16 possible number here, possible arrangement. Now think more like what's in the subset to be numbers like 12, 23. So in case you don't see what I'm talking about, 12, 23, 34, 14. You see how I arranged in the order, increasing order, right? If I move down to 3 elements, I have 1 2 1 3 2 3 1 2 3. So I can also have 1 and 2 and 1 2 single digits like that. But we need to constrain our problem because it goes only up to 9. Why? Because why is 9? We have, if we rearranged it the way how they want, from small to large, maximum we can have is this. Okay, there is no such a digit called 10, so we stop at 9. Okay, this is the largest number you can get, or meaning you can have as many as 9 elements. Okay, now to get that, I first need to discuss the formula. You see 1 2 4 8 16. This is the formula of 2 to the n. In other words, when we have 4 elements, we have 16 different kinds of subsets. As opposed to 0 element, I only have 1 subset. Now if I introduce using this induction method or inductive reasoning, when I have 9 elements, well, based on our first 5 element performance, we can deduce that it becomes 2 to the 9. Okay, and when you punch these, you'll get 512 different kinds of bags, if you want to think that way, or different subsets. Now if you got this so far, well, you're almost done, but this is not, unfortunately this is not the answer. You have to do more trimming here. First, we don't have such thing when we have 9 elements. Okay, we're not adding this, by the way, the elements. In this specific 9 elements, we have still the empty set. There's no such thing as empty digit, so we're gonna subtract 1. Okay, so now we have 511. Well, now if you go back to the question, it said we want the main integer to be greater than 9, meaning, you know, in our early example, you saw like 1, 1, 2. Remember, each subset becomes like a number, right? Well, these don't matter. So in our 9 element, collection, 1, 2, 3, 4, 5, 6, 7, 8, 9, each individual number must be also subtracted from the total number of our subset. So I have to also subtract 9 for each single digit. Okay, then when you perform this, so 512 minus 10, you get 502 different integers that satisfy the given condition. So that's our answer for number 5.